Welcome to today's math lesson. Our TEK is 8.5b. Our lesson target is that scholars will represent linear non-proportional situations with graphs and equations in the form of y is equal to mx plus b. And our DOL is given 4 problems. Scholars will represent linear non-proportional situations with graphs and equations with 100% accuracy. So we have 3 academic vocabulary words to go over. We have the words a linear equation, a slope-intercept form of an equation, and y-intercept. So for non-proportional relationship equations, it's always in the form of y is equal to mx plus b, as compared to for proportional relationships, it's y is equal to k times x. So k and m both represent the same thing. They're the unit rate, the constant of proportionality, the rate of change. The difference is there's a b. So in this case, it's plus b, but it could also be minus b, and b represents the y-intercept. So the y-intercept is 0, comma, whatever b is. So on this graph right here, this line, the y-intercept is this point right here. It's where the line intercepts or cuts across the y-axis. And linear equation and slope-intercept form, in this case, refers to this new equation that we're working with, which is y is equal to mx plus b. For this first problem, we have let's examine the linear relationship y is equal to 2x plus 5. We can create a table and a graph to represent the relationship. So we have our 3-column process chart. We have different x values already written for us, 0, 1, 2, and 3. We have our equation in the middle column, and lastly, we have our y values. Then we have a horizontal table, and so when x is 0, I'm multiplying 2 times 0 plus 5. So 2 times 0 is 0, 0 plus 5 is 5. So when x is 0, our y value is 5. When x is 1, I'm multiplying 2 times 1 plus 5. So 2 times 1 is 2. 2 plus 5 is 7. So when x is 1, y is 7. When x is 2, I'm multiplying 2 times 2 plus 5. 2 times 2 is 4. 4 plus 5 is 9. So when x is 2, our y is 9. When x is 3, I'm multiplying 2 times 3 plus 5. So 2 times 3 is 6. 6 plus 5 is 11. So when x is 3, y is 11. And from here, we have our proportional equation, which is y is equal to k times x. If we were to find the constant of each of the coordinate pairs, we'd use the equation y over x. So for this first point right here, 1, 7, our y value is 7, our x value is 1. I want to see if all of the different coordinates or all of the different points have the same unit rate, constant of proportionality. So then for the second point right here, 9 is our y value, 2 is our x value. And for this last point right here, we have 11 is our y value, 3 is our x value. So we want to see if they're all equal to each other. 7 divided by 1 is 7. 9 divided by 2 is 4.5 or 4.5. 11 divided by 3 is 3.6 with the 6 repeating. So as you can see, they're all not equal to each other. The constants of proportionality are not the same. So k is not constant. Therefore, this is not a proportional relationship. And another way to say not a proportional relationship is non-proportional. So we can now use the ordered pairs to create a graph of the relationship. So our x-axis, each of the units is being counted by 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our y-axis is also being counted by 1. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we're going to graph 0, 5. So we start on our origin and we move 5 units up. Then for 1, 7, we start on our origin. We move 1 unit to the right, 7 units up. Then we have 2, 9, starting at the origin, 2 units to the right, 9 units up. Then we have 3, 11, so starting at the origin, 3 units to the right, 11 units up. And so that is the graph of 2x plus 5 is equal to y. For this first algebra problem, it reads, a lake has an average depth of 4 feet. A new dam has just been completed and the average depth of the lake will increase by 3/4 foot each day for the next 8 days. The equation y is equal to 3/4 x plus 4 gives y the average depth of the lake after x days. Draw a graph of the equation, describe the relationship. So we have a table right here, and I already input the x values of 2, 0, 2, 4, 6, and 8. And I'm going to go ahead and plug in these different x values into our equation to get our y values. So when x is 0, I'm doing 3/4 times 0, which is 0 plus 4, and that gives us 4. When x is 2, I'm doing 3/4 times 2, and then adding 4 to that. And so on Desmos, we can go ahead and plug in 3/4 times 2 plus 4, and that gives us 5.5. Then we have to do 3/4 times 4 plus 4, and that gives us 7. Then 3/4 times 6 plus 4 is 8.5. And then 3/4 times 8 plus 4, and that gives us 10. So now I have to label my x and y axis, and I have to figure out what each unit should represent. So what value should one unit have? So as you can see, the range in my x values are 0 to 8, and we have 10 different squares. So I can have each unit represent 1. So if that's the case, this will be 1, this would be 2, this would be 3, 4, 5, 6, 7, 8, 9, 10. And then our y values range from 4 to 10, but of course we have to start at 0. So our y values can also be counted by ones. So if this is 1, this would be 2, 3, 4, 5, 6, 7, 8, 9, 10. From here, I'm going to have to graph each of the points. So we have 0, 4. So starting at the origin, I'm moving 4 units up. Then we have 2, 5.5. So starting at the origin, 2 units to the right, 5.5 units up. So if this is 5, this is 6, 5.5 will be in between. Then we have 4, 7. So starting at 0, moving 4 units to the right, 7 units up. And then 6, 8.5. Starting at the origin, moving 6 units to the right, 8.5 units up. So if this is 8, this is 9, then 8.5 is in between. And then our last point is 8, 10. So starting at the origin, moving 8 units to the right, 10 units up. And then I have to draw a line through the points to make my graphed line of the points. So in this problem, they gave us the equation, but if we didn't have the equation and we just had to write an equation from the situation, let's go ahead and review what that process would look like. So a lake has an average depth of 4 feet. That's where it starts. Our starting value is also known as our y-intercept. And then it says the average depth of the lake will increase by 3/4 foot. So increase means that we're adding 3/4 foot each day. Each is the key word that tells you that 3/4 is our constant of proportionality or our unit rate. So I'm going to have x behind the 3/4, and x is going to represent the number of days. And then y represents the average depth of the lake. So as you can see, just from the verbal description, we can write our own equation. 4, which is the starting depth or the initial amount, is our y-intercept. Then we have to figure out what our unit rate, our rate of change, or our slope is. And in this case, the key word is each. Sometimes it's every, sometimes it's per, and that tells you that that number is the slope, or the constant of proportionality, what goes in front of the x. And so we have 3/4 x plus 4 is equal to y, which matches the equation that was given to us in the problem. We also have anchor charts to help us understand the differences between proportional relationships and non-proportional relationships. So as we've already gone over, the equation for proportional relationships is y is equal to k times x. For non-proportional, it's y is equal to mx plus b. M and k are both representing the change of y over the change in x. For non-proportional relationships, b represents the y-intercept, and that's always written as 0. Its coordinate is 0, comma, whatever the b value is, and it's the starting point or the initial value. Then for the tables, we fill it out in the same way. The graphs look pretty similar. As you can see, there's straight lines, except for the graph of proportional relationships. It goes through the origin. It cuts through that center, that point 0, comma 0. But for non-proportional relationships, it is either above or below the origin, but it's still a straight line. So for this weed-do problem right here, it reads, the equation y is equal to 2x plus 5 gives the total height y of a plant in an experiment that was 5 centimeters tall at the beginning of the experiment and grew 2 centimeters each day. Represent this linear relationship on a graph. So we have our table, and I already input different x values. So we have 0, 5, and 10. All we have to do is plug in the different values into the equation to figure out what our y value is. So we have, when x is 0, we're multiplying 2 times 0, which is 0. 0 plus 5 is 5. When x is 5, we're multiplying 2 times 5, which is 10. 10 plus 5 is 15. When x is 10, we're multiplying 2 times 10, which is 20. 20 plus 5, which is 25. So from here, we're going to have to label our graph. Our x and our y-axis are already labeled, but we can see that the range of x values is from 0 to 10. So this point right here will always be the origin, which is 0. And so since there's 10 boxes, we can say that each box or each unit represents a value of 1. So I'm just going to label every 2. So we have 0, 2, 4, 6, 8, 10. And then as you can see, the range in our y values is from 5 to 25. So if right here is 0, we have to go all the way to 25. So we have to decide, do we want to count by ones? Well, there's not enough boxes in this graph for that. Can we count by 2s? There's still not enough boxes, because if we counted by 2s, we'd only get up to 20. So I'm going to decide that each unit is going to represent a value of 5. So 5. So we have 0, 5, 10, this will be 15, 20, 25, 30, 35. Okay, so now I can graph my points. So we have 0, 5. So starting at the origin, I'm moving up the value of 5, which is just one box or one unit here. And then we have 5, 15. So starting at the origin, I'm moving over 5 spaces to the right, and I have to move up to 15. So that was 3 boxes up, 3 units up. Then I have 10, 25. So starting at the origin, I'm moving 10 units to the right, and I have to find the value of 25 on the y-axis, which is right here. So now that the points are plotted, I can connect the points with a line, and that is our graph right here. So again, if we weren't given this equation, from the verbal description, we could write our own equation. And let's look back. So it says the total height y of a plant, so we have y is equal to, y represents the height in an experiment that was 5 centimeters tall at the beginning of the experiment. So our 5 centimeters is going to be our y-intercept, because it's our initial value. And then it says, and grew 2 centimeters each day. So our keyword is each. That tells us that our 2 is our constant of proportionality, also called our slope in this case. And grew means that we're adding, since we're adding height. So it should be y is equal to 5 plus 2x. And x is the number of days. And as you can see, that matches the equation that was given to us, y is equal to 2x plus 5. They just have it switched around. Lastly is the DOL, which is in a Google form. Thank you so much for following along and paying attention in today's lesson, and see you in the next math video.